Planes rarely crash because of one big mistake. They crash because of one tiny part no one notices. Today, we're going to show you how a small, seemingly insignificant component can determine life or death in the sky. And by the end of this video, you'll never look at a commercial flight the same way again. Aircrafts are complex machines, and every system plays a critical role. Some of the most important components include the engine control systems, which manage fuel and power, pitot tubes, responsible for measuring airspeed, and the flight control surfaces, including ailerons, elevators, and the rudder. According to the Federal Aviation Administration, the FAA, a modern commercial aircraft contains over 6 million individual parts, and the failure of even one can trigger a catastrophic chain reaction. Each of these components is crucial, but one part is even more critical than the rest. That part is the Flight Control Actuator, also known as the Servo actuator. This tiny device converts the pilot's stick inputs into actual movement of the plane's control surfaces. Without it, even the most experienced pilot cannot maneuver the aircraft. Aviation Week and Space Technology magazine describe the Flight Control Actuator as, quote, the silent backbone of modern fly-by-wire aircraft, a component so embedded in flight systems that most passengers never know it exists. This small actuator has been responsible for real plane crashes, and we'll tell you the full details at the end of this video. So how does this tiny actuator have such a massive impact? Every time a pilot moves the control stick, the Flight Control Actuator transmits that command to the corresponding control surfaces, the ailerons, elevator, or rudder. If the actuator jams or fails, the control surfaces freeze. The autopilot immediately disconnects, alarms sound in the cockpit, and the pilot attempts to regain control, but nothing works. The plane begins to pitch, roll, or stall uncontrollably. According to a technical report published by NASA's Aviation Safety Reporting System, known as ASRS, actuator-related control surface failures are among the top 5 mechanical causes of loss of control incidents in both commercial and general aviation. This is the chain reaction that transforms a small component failure into a catastrophic disaster. Now, here's something most people don't know. There are actually 3 main types of flight control actuators used in modern aviation. First is the hydraulic actuator, the oldest and most common type, used in aircraft like the Boeing 737 and Airbus A320. Second is the electro-hydraulic actuator, which combines electrical signals with hydraulic power for precision control. And third is the electromechanical actuator, or EMA, the newest technology being adopted in next-generation aircraft like the Boeing 787 Dreamliner and Airbus A350. According to a 2023 industry report published by Markets and Markets Research, the global aircraft actuator market is valued at over $16 billion and is expected to grow significantly as airlines upgrade aging fleets. The reason? Engineers discovered that older hydraulic actuators, while reliable, carry a hidden risk. Hydraulic fluid leaks near hot engine components can cause fires. The move toward electromechanical systems is a direct response to decades of actuator-related incidents flagged by the National Transportation Safety Board, the NTSB. Imagine the cockpit, warning lights flashing, alarms blaring, the pilot desperately trying to regain control. Outside, the plane tilts slightly, struggling to respond to the controls. Even minor turbulence now becomes critical, as the frozen actuator ensures the plane cannot follow pilot commands. CNN aviation correspondent Richard Quest, in a 2021 segment on aircraft safety systems, explained that in a fly-by-wire aircraft, the actuator is essentially the muscle of the aircraft. Without it, the pilot has the brain and the intention, but zero physical ability to move the plane. The tiny actuator may be hidden deep inside the control system, but its role is pivotal. One small failure, and the aircraft becomes a machine in chaos. This is not a new problem. Aviation history is filled with incidents directly linked to actuator failures. In 1994, the crash of USAir Flight 427 near Pittsburgh, Pennsylvania, killed all 132 people on board. The NTSB investigation, which lasted over 4 years and became one of the longest in aviation history, ultimately traced the cause to a jammed rudder actuator, a single component no larger than a human forearm. The Pittsburgh Post-Gazette covered the investigation extensively, reporting that Boeing initially resisted the findings before the NTSB confirmed the actuator as the primary cause. Following this disaster, the FAA mandated immediate redesigns of rudder actuator systems across the entire Boeing 737 fleet, a decision that affected thousands of aircraft worldwide. Again, in 1996, United Airlines Flight 585 was re-examined, and investigators confirmed a similar rudder actuator issue had caused that crash as well. 2 crashes, same tiny part, hundreds of lives lost. But this isn't just history. On September 4th, 2022, a de Havilland, Canada, DHC-3 Otter aircraft suffered a flight control actuator failure near Whidbey Island, Seattle, Washington, USA. The actuator jammed, leaving the plane uncontrollable. The aircraft entered an unrecoverable descent, tragically claiming 10 lives. The Seattle Times reported the incident as one of the deadliest small aircraft crashes in Washington state in over a decade. The NTSB opened a full investigation, with early findings pointing directly to a flight control system malfunction. NBC News and ABC News both covered the crash, with aviation analyst John Cox telling ABC News that, quote, "In small aircraft, a single actuator failure with no redundant backup system leaves the pilot with almost no options." This real incident highlights why every single component in an aircraft, no matter how small, is absolutely critical. So what is being done to prevent this from happening again? Quite a lot, actually. The FAA issued updated airworthiness directives in 2023, requiring enhanced actuator inspection intervals for over 40 aircraft models operating in the United States. According to reporting by Aviation International News, AIN, major carriers including United Airlines, Delta Airlines, and American Airlines have voluntarily accelerated their actuator inspection programs beyond FAA minimum requirements. Airbus, in its 2023 safety report, confirmed that all A320 family aircraft now undergo actuator load testing every 3,000 flight hours, reduced from the previous 5,000-hour cycle. Boeing's official maintenance documentation, publicly available through its maintenance planning data system, lists actuator integrity checks as Priority 1 items, the highest level of urgency in their maintenance schedule. The industry is listening. The question is it listening fast enough? The good news is that technology is advancing rapidly. MIT's Department of Aeronautics and Astronautics published a 2023 research paper exploring self-diagnosing smart actuators, devices embedded with sensors that detect internal stress and signal potential failure before it occurs. The paper, covered by MIT Technology Review, described these smart actuators as, quote, "a potential revolution in predictive aviation maintenance." Meanwhile, the European Union Aviation Safety Agency, EASA, is currently funding a multi-million euro research program called Clean Aviation, which includes next-generation electromechanical actuators designed to eliminate hydraulic fluid risks entirely. According to Forbes Aerospace coverage of the program, these new actuators are expected to enter commercial service by 2028. The aviation industry learned its lessons the hard way, through tragedies. But those lessons are now driving real, meaningful change. The Flight Control Actuator may seem insignificant at first glance, but it literally controls how a plane moves in the sky. From the USAir 427 disaster in Pittsburgh to the Whidbey Island tragedy in 2022, history has proven, repeatedly, that small parts carry the biggest consequences. Respect the details, because in aviation, small things can mean life or death. If you learned something new today, like this video, share it with someone who flies, and subscribe for more aviation documentaries that go deeper than the headlines. Stay curious and stay safe.